Okay, just like we had shortcuts that we were allowed to use to prove that two triangles were congruent to each other, we can also take some shortcuts to prove that two triangles are similar to each other. So, if every time I was trying to prove that two triangles were congruent to each other, for example, if I was trying to prove that these two triangles were congruent to each other, if every time I had to say angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and then show that the ratio of AB to ED is the same as the ratio of BC to EF, which is the same as the ratio of AC to DF. Wouldn't that be such a pain? That would be so annoying if I had to prove all of that stuff was that all of these angles were congruent and that all of those ratios were proportional. Like, that would be such a pain. So we are allowed to take certain shortcuts to prove that two triangles are similar. And it's important to note, the shortcuts for similarity are different than the shortcuts for congruency. We had 5 shortcuts to prove two triangles were congruent: side, 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 angle, 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 side, and hypotenuse leg. There's only 3 shortcuts to prove that triangles are similar, and they're different, and they mean different things. So the first one is angle, angle. And if you remember, for congruency, angle, 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 no, no, no. We are not allowed to use angle, angle to prove two triangles are congruent, but we are allowed to use angle, angle to prove that two triangles are similar. And notice, it's not angle, 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 it's just angle, angle. And we only need 2 pairs of angles that are congruent. So, if 2 angles in one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So, angle A, if angle A is congruent to angle X, and angle C is congruent to angle Z. So if 2 pairs of angles are congruent, that's enough information to go ahead and say, oh, that's all I need to know to say triangle ABC is similar to triangle XYZ. That's all I need to know to prove that those two triangles are similar. So here are some examples. I see that angle C is 78 degrees, and so is angle F. So angle C is congruent to angle F. And angle A is 57, and so is angle D. So angle A is congruent to angle D. That's enough info to say, I guess I should use a different color. It's enough info to say that those two triangles are similar. I can say triangle ABC is going to be similar to triangle DEF by angle, angle. Here is another situation. This is one where I want to look at my little triangle at the top, triangle RST. And then my big kahuna triangle, RUV. It's like I have a triangle within a triangle. These two triangles overlap. They're like, the little orange one is fitting perfectly into the purple one. They share this top angle. So this angle R and this angle R are congruent. So those top angles are congruent because those triangles overlap, and then these angles that are 48 degrees, those are congruent. So because angle SRT in the top triangle is congruent to angle URV in the purple triangle, and because angle S is congruent to angle U, I have enough info to then say that triangle RST should be similar to triangle RUV by angle, angle.